Today we are going to learn a few of the basics about MATLAB. Specifically, we will go over the creation of variables, vectors, and plotting. So this is the command window. You can type in one-line commands into this window and MATLAB will display the result. So let's try an example. We'll have x equal to 3. Now you can see when we execute that command, MATLAB spits out an answer right below the command, and then to the right in the workspace our variable x is saved with a value of 3. Now once a variable is saved in the workspace, we can use that same variable for to do additional commands with. So for example, we can do x plus 1. Once again, MATLAB spits out an answer below the command, and in the right we can see our answer with a value of 4. Now what we can do is suppress the command so that MATLAB doesn't spit out an answer, and still have that value saved in the workspace. So for example, we can do y is equal to x plus 1. And then to suppress the command, we use a semicolon. And now see, when I run it, MATLAB does not report an answer. But we can see that our variable y is still recorded in the workspace. So let's clean up what we've done so far. And to do that, we use the clear all command. That gets rid of our variables in the workspace. And to clear the command window, we use the command clc. Instead of using a command window to input commands, we will usually create a new script file, which is up here on the left. A script file allows line after line of command to be executed rapidly, one after another. In MATLAB, these script files are saved with the .m file extension, and these files allow you to save a MATLAB program and run it later. So, usually when you start a new program, it's a good idea to write the clear all and clc commands, so that way anything that was done before you run your script is taken care of and deleted. Now also, instead of writing a variable like we did last time, we're going to make a vector. We're going to have our variable x, which is going to be equal to progression of numbers from 0 through 10 in a step of 1. And then we're going to suppress that. And also, let's make another new variable. We'll call it y1, which we're going to set equal to x. And then, well, we need to suppress that. And then we're going to plot the results. So we're going to plot y1 with respect to x. And before you run it, you need to save it. And so we'll just call this untitled. And when we hit run, you'll see that we get our plot. And also, if we go to the command window, you'll notice that because we suppressed our commands, nothing was reported. So let's go back to our script. And let's make another variable. We're going to call this one y2, and we're going to make it equal to x plus 1, and we'll suppress that as well. So one thing to take notice of right now is that we have a vector plus a scalar, and in MATLAB how this will be treated is this scalar will be added to each number in the vector. And so also let's plot this in the same graph. So we're plotting against x again. This time we're plotting y2. And after you saved it the first time, whenever you run it, it also saves it again. So we can just click run this time. And if we go look at our figure, we see we have our two plots, just like we should. Now, a plot doesn't say anything without descriptions though. So let's add a title, a legend, and axis labels. Which these are the things that will be required for anything that you plot in DMC Lab. So, to add these things, we just need to add title with parentheses and apostrophes in the center, and then we can call it whatever we want. So we'll just call this one graph 1. And then to add our x-axis label, the command is xLabel with the parentheses and the apostrophes, and we will call this the x-axis. And the y is very similar, y-label. Same thing, and we'll just call this one y-axis. And then, last but not least, we need to add the legend. And this one's a little bit different because we have two separate things that we were plotting. We need two sets of apostrophes with a comma separating them. And so we'll just call them exactly what they are. So we'll say y1 equal to x, and then y2 equal to x plus 1. And then we run it. And there we have our results with all our different labels. And also you can see the legends over the results, but you can just click and drag it and move it out of the way. Instead of showing the plots in the same graph in one figure, we can instead show the two plots in different figures. To start, all we have to do is copy our plot command and then paste it down here. Now we need to get rid of the second part of this original plot command and the second part of its legend. And then for the second plot, we need to get rid of the first part, change its name to graph 2, and get rid of the first part of its legend. Now we're not done yet though, because like this, you won't actually get to see both plots. Here, let's go ahead and see what happens. We run it, and we get one figure with just graph 2 showing. Now see, we can fix that by including the figure command. So we designate that this plot goes in figure 1 and this plot goes in figure 2. What was happening is it was putting both of them in the same figure originally, and what happens is instead of just sharing the figure, the plot just completely overrides what was originally put. So when we include these commands, you can see that we get figure 1 and figure 2 with our separate graphs. Now, if you wanted to have two graphs in one figure, there is another command to do that. First, we need to get rid of the figure command, and this one down here as well. And instead, the command we're looking for is subplot. Now, subplot needs 3 numbers. And the first 2 specify the numbers of rows and columns that the figure is going to be divided into. And the last number is the position that the plot will take. So, for example, we're going to do 2, 1, 1. And by doing this, I'm splitting the figure into 2 rows with just 1 column, with this plot taking the first or top position. And so by splitting it into 2 rows and 1 column, I'm effectively just splitting the figure in half horizontally. And I'm going to include the same command down here at the bottom as well, except instead of 2, 1, 1, we're going to have 2, 1, 2. Now what this does, of course, is this means that this plot will have the bottom position in the figure. So when we run it, there you go. One figure with our graph 1 on top and graph 2 on the bottom.